Tf.Multiply versus Tf.Matmul to calculate the dot product. I have a matrix of vectors x with shape 3, 4, and I want to calculate the dot product between each pair of vectors x1.x1 and x1.x2, etc. I saw a cosine similarity code where they use Tf.reduce_sum, Tf.Multiply, x axis equals 1. To calculate the dot product between the vectors in a matrix of vectors. However, this result and only calculates the dot product between xi. I use Tf.Matmul, x transpose underscore b equals true, which calculate the dot product between every two vectors, but I am still confused why Tf.Multiply didn't do this. I think the problem with my code. The code is the output is I would appreciate any advice.
Tf.Multiply, x, y, or the asterisk operator does element-wise multiplication so that, whereas Tf.Matmul does matrix multiplication so that. Using Tf.Matmul, x transpose b equals true means that you are calculating x to the power of t, where t indicates the transposing of the matrix and is the matrix multiplication. Tf.reduce_, axis equals 1 takes the sum along first axis, starting counting with 0, which means you are summing the rows. This means that. So that is the one you want if you only want the norms of each rows. On the other hand, so that is what you need if you want the similarity between all pairs of rows.
What Tf.Multiply, x does is essentially multiplying each element of the matrix with itself, like would turn into. Whereas Tf.reduce_sum, axis equals 1 takes the sum of each row, so the result for the previous example will be, which is exactly, by definition, equal to x0 column at x0 column, x1 column at x1 column. Just put it down with variable names, a, b, c, d, instead of actual numbers, and look at what does Tf.Matmul, x, and Tf.Multiply, x do.
In short, Tf.Multiply does element-wise product, whereas Tf.Matmul does actual matrix multiplication. So Tf.Multiply needs arguments of same shape so that element-wise product is possible, i.e., shapes R, N, M, and N, M. But Tf.Matmul needs arguments of shape N, M, and M, P so that resulting matrix is N, P, usual math. Once understood, this can be applied to multidimensional matrices easily.
For what it is worth, stocks equals Tf.Matmul, x transpose underscore b equals true, is functionally equivalent to. If x is n-dimensional. Dot product between different matrices x and y. Tf.Matmul, x, y, transpose underscore b equals true, can be accomplished the same way, by using Tf.expand_dims with axis equals -3 on y instead of x.
If you want to support the channel, please consider liking and subscribing.